What if the hardest part of cancer treatment isn't the cancer itself, but the treatment we use to fight it? My name is SARANYAPONG JAIHOW, and today I'll be presenting Oncobot, a conceptual medical technology that explores how AI and intravascular microrobotics could make cancer treatment more precise, localized, and less invasive. Chemotherapy is designed to kill cancer cells, but once injected, it circulates throughout the entire bloodstream. As a result, healthy cells are damaged alongside tumor cells. This lack of targeting leads to severe side effects, reduced quality of life, and limited treatment efficiency. At its core, the problem is simple. We are treating a localized disease using a systematic approach. The challenge extends across multiple cancer treatments. Chemotherapy lacks specificity, radiation is limited by location, and surgery is often impossible for deep or diffuse tumors. In many cases, only a small fraction of administered drugs actually reaches the tumor. This reveals a clear clinical gap, a lack of precision, control, and localized delivery in cancer therapy. So what if treatment could be delivered only where it's needed? Oncobot is a conceptual AI-assisted intravascular microrobot designed to travel through blood vessels, identify tumor-associated regions, and deliver chemotherapy directly at the tumor site. By localizing drug delivery, Oncobot aims to reduce systemic toxicity while improving treatment precision. Oncobot operates in three main steps. First, it navigates blood vessels using AI-guided path planning and real-time vascular sensing. Second, it detects tumor-associated vascular anomalies and chemical signals. Finally, it releases chemotherapy locally at the tumor site, rather than throughout the entire body. This allows Oncobot to function as an intelligent, decision-driven delivery system, not just a passive drug carrier. Placing a robotic system inside blood vessels raises an important question. How does the body respond? Oncobot is designed with biocompatible surface coatings that reduce immune cell attachment and vascular irritation. It's smooth, non-reactive materials and short intravascular residence time help minimize inflammation and immune activation. Localized drug release also avoids widespread immune responses and systemic toxicity. Like all medical innovations, this concept has limitations. Precise micro-scale propulsion and control in complex blood flow remain major engineering challenges. Long-term biocompatibility and immune interactions require extensive in vitro and in vivo validation. Future work would focus on advanced AI algorithms, improved materials, alternative propulsion methods, and integration with medical imaging to support safe clinical translation. So, what does Oncobot ultimately represent? It demonstrates how AI-guided intravascular microrobots could enable precise, minimally invasive cancer therapy by shifting treatment from broad systemic intervention to intelligent site-specific delivery. This concept highlights a pathway towards safer and more effective cancer care. This project is grounded in open access scientific literature covering intravascular microrobotics, AI-guided navigation, targeted drug delivery, and cancer biology. These sources ensure that the concepts presented remain scientifically plausible and aligned with current biomedical research. Oncobot is not a finished medical device, but a forward-looking research concept exploring what may be possible when AI and microrobotics converge in medicine. Thank you very much for your time. I'll be happy to answer any questions.
Thank you very much for your interesting talk. So you said immune response is not going to be a problem. Is that right?
It might be a problem since the body doesn't take kindly to foreign objects, right? Mm-hmm. It tries to get rid of anything that's not native to the body. So the immune system part is not like a foolproof plan, but it like we have ways to like avoid white blood cells. For example, like in the presentation, like surface coating and short residence time. Yeah.
So what is this Oncobot this robot is made of?
Again?
What is this made of? What is this composed of?
It's components is probably going to be made of metal, I guess, but the surface coating is probably going to be like fats or proteins. I'm not really sure the specific materials that are going to be used because I haven't dove deep into this, but I can say for sure that if this is just an idea, I don't really have any info to point out any materials.
Okay, so after you're targeting to the specific location, after it's done, its work, you have to remove it from the body, right? How can you remove it?
So, yes, that is an important concern. I've thought about that, and the only way I see fit is for Oncobot to first enter from one side, deliver the medicine to the tumor, and then we have another hole, the exit hole, and it goes out there. So there's going to be an enter hole and an exit hole.
So that means that's not biodegradable?
Biodegradable technology is very, what do you call it? It's very limited in research. Oncobot, in a perfect world, it could be biodegradable, but with current biomedical research and limitations, that doesn't seem to be like plausible in the grand schemes of things.
So once this enter the vasculature, can this robot just move by itself, or can we also need to control the outside the body?
Yeah, it does move by itself. The robot goes through lab testing first. It goes into a simulation where it encounters various scenarios and what to do in those scenarios. So for this robot, I want it to be like making decisions on its own rather than having any human intervention.
If something happens, let's say it is out of control, so how can you remove this?
Yes, that's also a very important concern. I really want Oncobot to not have that problem, but that's also a serious issue. So if it goes out of control, I would like it to basically have human takeover or have a built-in system where it either self-destructs or it does something else. I'm not really sure what else it can do if it can counter that.
And also, per person, how many robots do we need to
Yes, so Oncobot probably So Oncobot is the size of like 5 to 8 micrometers. Basically the same size as red blood cells. So, and it should be able to carry a good amount of chemotherapy drugs. So I'll say only like a bit 5 to 10 should be enough, because it's not a systemic, like you don't need chemotherapy to go throughout the entire body, just one location, right? So it needs way less drugs than chemotherapy.
I think to promote the efficacy, probably they need to move together, not just, like a 5 to 10 robots working together. Otherwise, so one robot is here, another one there. So then that's not really efficient to treat the cancer, I think.
Yes, I'm not really sure how it's gonna work. I'm sure there's some way to make it more efficient, but as current research and for the research I'm done, I don't have a clear answer to that.